13.7, which asks you to use phase diagrams to identify specific states of matter, the triple point, the normal melting point, the normal boiling point, and the critical point. So this is the video that you were supposed to have watched last weekend. Many of you did get that taken care of. Thank you. I appreciate that. So the first question is, what is the temperature of the normal melting point according to the graph? So the normal melting point is the melting point that occurs at standard conditions. So normal melting point and boiling point are at standard pressure, which you might remember to be 1 atm, 760 millimeters of mercury, or 101.325 kilopascals. So here's my pressure. Here's my standard pressure, which is 1, and then I drop this down and I see that it's going to be somewhere in the ballpark. It's a little bit more than 100. I'm going to say maybe 120. So I'm going to say it's about 120 degrees Celsius. You may recall that the triple point was the point at which all substances are at equilibrium and or they sort of exist at the same time. So that is where your triple point is. And so the pressure and temperature of your triple point, I'm going to drop this down, is like less than 100. And it's somewhere. So I'm going to say its temperature is something like about, 90 degrees Celsius. And its pressure is somewhere around 0.65 degree atm. And then what is the critical pressure? Okay. So you might recall that the critical pressure is the last point or the last temperature at which a liquid can exist. So this is my critical pressure or my critical point. And so my critical pressure, if I go all the way across here, looks like it's about 1.50 degrees atm. And then it says, what letters describe the line that defines the equilibrium between solid and gas? So between solid and gas would be this line right here. That's where we can have sublimation and or deposition occur. So I would say that the best letters that describe that are DB or BD. Either is fine. And then give a temperature and a pressure where the unknown substance would only be a solid. And so since this area right here is where solids exist, anywhere in that area would be a good pressure and temperature. So I just chose to use the just a random spot. I used like something like negative 100 Celsius, and so I went up and something easy like 0.75 atm. Now, again, you're probably going to want to make sure that you have reviewed that video because there's other points on this graph that are things you're expected to know, but they weren't asked here. So does anybody have any questions about this graph? All right, then. Your